Yeah, g'day, Mark here, and welcome back to my channel. Now, a while ago, I reground a bunch of end mills, carbide end mills, and I didn't do a very good job of it. And the main thing I identified was that most of my diamond cup wheels have got a rounded over corner, and therefore they couldn't really get all the way into the center of my end mill. So how do you go about dressing a diamond wheel? So this is one of the regrinds I did the other day, and can you sort of see how right in the tip there, there's kind of a raised portion right in the middle. And that's because my grinding wheel had worn with a curve on the outside of it. And that's what I'm trying to address. Right, so I own a total of 6 diamond wheels, and all of them, except for this one, which I don't think I've ever used, have got those kind of rounded off shoulders. My rough cup wheel's probably the worst. My fine cup wheel's not as bad, but it's still not great. This has got a big sort of a angle on it. And the most recent one I bought, which is for gashing the ends of end mills, is too thick at the end. So, how do you dress them? As far as I can tell, there's sort of 2 major methods. One is you run across the surface while it's running with a very soft metal. Pure molybdenum seems to be the best choice, and that picks up the diamond grit, rips it out of the binder, allowing the binder to wear away, and you can reshape it. Unfortunately, I don't have any molybdenum. The second way of doing it is just have a fight of abrasive versus abrasive. The diamond will win, but it'll also lose some of its thickness at the same time. You quite often see this done where people take an old, in this case very heavily worn and not flat stone, clamp it to a milling machine, mount the cup, spin it, and just run it backwards and forwards across the stone. Stone gets ground away pretty fast, but the diamond wheel gets ground away as well, a bit slower. One of the nice side benefits is it takes off all of the unevenness and you end up with a nice square stone again. So I am quite attracted to that method, but that also has a disadvantage. If I bolt this down and rotate across the top of it, yes, I'll end up with a nice flat, newly dressed surface with a sharp edge, but it will only be a flat surface. For a lot of tool grinding jobs, you really don't want the cup wheel to be perfectly flat. You want it to be dished inwards, taking away metal here so that it only cuts at the outer edge. Now for the straight wheel, that's less of an issue. So what I might do is clamp this stone down to my surface grinder, mount up this wheel, see what that does to clean up both the wheel and the stone. Well, you're probably not supposed to do this dry, but I don't have the coolant system set up yet. But you can see it is already starting to take off the high spot. I've just done those first 2 passes, so let's do a bunch more passes and see if I can get this to dress down nice and flat. Well, that's actually been working quite well. I've now got a nice sharp corner back on the edge of that again. It appears to be pretty flat. The stone is now also nearly flat with just a bit of a divot in the middle. Might as well give it one more roughing pass. I don't think the diamond needs it anymore, but since I've got this far, I might as well flatten off the rest of that stone. Now I'm sure at this stage someone's dying to tell me that I'm halfway to a pair of precision ground stones, but I've already got some. Years ago, before I got the surface grinder, one of my generous viewers sent me a pair of precision ground stones, which I've looked after. I've only ever used them for precision jobs. Any rough, imprecise jobs were always done with this shop stone. This is going to stay my shop stone. It's not going to stay flat, but at least it's now a lot flatter than it was before. Now I won't waste diamond thickness to flatten off the other side. Sooner or later it'll get damaged again, and then I can use the other uneven side of the stone to flatten it a second time. Well, for everyone in the Northern Hemisphere, I hope spring's also arrived for you. All our tulips are out. Can't mow the lawn at the moment because it's full of them. Apple tree doesn't have many blossoms, so it doesn't look like I'm going to get many apples this year. Oh well. Mail time. So this is just a soft aluminium oxide dressing stick. This is what you use for dressing diamond wheels, is my understanding. Some wire. And in my last video, I tried out a set of sort of additional over-the-head magnifiers for doing close-up work. And basically, they were crap, so I sent them back. I got a lot of recommendations on these MagniVisor being very good, so let's give that a go. It's a bit more expensive. The crap ones cost 30 bucks. This was like 60, but 30 bucks not working versus 60 hopefully being really good should make quite a difference. Kind of a cool sticker. I think I'll stick that somewhere. Four different lenses. Let's try like a medium one first, I guess. So the flat part of the lens should face inwards. Well, the headband's easy to adjust and seems comfortable enough. Ah, yeah. Now I can definitely see why people like this. This really is quite easy to use. Gets out of the way nicely. Can flip it down easily. Yeah, I can see this one being a keeper. Now I can quickly see what I did wrong on my end mill grinding. Becomes much more obvious once you can see things. Thanks for the recommendation of the MagniView, or what's called MagniVisor. So at this point, the diamond wheel is now dressed back into the correct shape, but the binder will now be right up at the surface. The little bits of diamond will be barely sticking through, and if you try and grind with it, it'll just load up and heat up really fast. So the next thing that's needed is to attack the binder enough to get the sharp grains of diamond sticking out so it cuts freely. And that's where this comes in. I was watching Rob Renzetti's video on this, so what I need to do is just start the spindle, stop it, and as it winds down, just touch this against it. And initially it probably won't cut too well because the diamonds aren't sticking out enough, but it should quite quickly take out the binder, the diamonds will cut better, and this will start abrading away faster. And when that's done, job's done. Oh, well, there we have it. The first diamond wheel dressed and ready to go. Now, a rather different method, which is often used to put a specific profile onto a disc, is to use an undriven spindle. This is just an old Sherline spindle, which I've had lying around for years. So you clamp a grinding wheel into the spindle, run that backwards and forwards in the tool grinder at the angle you want. It gets driven by the diamond wheel, obviously gets worn away pretty quickly, but should give the correct profile to the diamond wheel. And I figure I can sort of bodge up something like this, just to hold the spindle, clamp this down to the bed of my Carson Mark 1 tool and cutter grinder, and give that a go. As is often the case with this machine, I'm going to need a spindle extender to move this cup wheel out a bit further. So I'm already quite a long way in on my cross slide. These spindle extenders get used a lot on the Carson. I'd say I'm probably out on the extension more often than I'm on the base spindle. It's a bit of a pain that the main spindle doesn't have any form of flat on it. So it's actually quite difficult to get these back off again once they've sort of been on for a while. Now the whole aim of the game here is to try and cut this cup wheel a couple of degrees hollow. You can see at the moment it's really tapering out this direction, and I want it to taper in this direction. So to do that, I need to swing the whole table. One thing that adds a lot of flexibility to the Carson tool grinder is the way you can swing the whole table right round through 90 degrees to do a lot of jobs on the edge of a wheel out here. But in this case, I'm just looking to go a couple of degrees beyond square to give me that taper. I'm just going to eyeball it off the T-slot of the table. That's looking good there. Now I'm guessing this gets done roughly on center height, so I'll just drop that wheel down. Well, it is sort of working on the wheel, although it's not giving me the angle I want yet. I think the problem I've got is this wheel is also heavily worn at the front and not at the back, so I need to concentrate on doing the dressing back here. Okay, I had the big surface grinder vacuum at the bottom, but I forgot to put the vacuum cleaner hose in here at the top to get this dust out of the actual wheel shroud. Right, let's try that again. This is also going to be some of the like world champion worst dust ever. Just put a magnet on there just to sort of cover this up a little bit. Unfortunately, there's no way guards on the Clarkson ways, so they're already pretty heavily worn from various sort of dust and crap. Well, it's not really a slow process. I've now got a couple of degrees of clearance there on my wheel. So I'll call that one done and do the other ones. Right, well, this was a much finer wheel. I think that's a 600 grit, whereas the other was 150 or 180. So you can see that it loaded up this wheel much faster and didn't cut as cleanly. I guess what I need to do is dress this wheel while it's running on this wheel. Let's try that. Well, that does improve things a bit, but it's not ideal. I think I need a different grit or binder in the dressing wheel to make the system work with these very fine diamond wheels. This is now the third wheel, the Gashing wheel, kind of a plate wheel I guess is the shape you call it. Now this has an aluminium binder that goes quite a long way out, so I've got to sort of wear off some of the aluminium, which doesn't grind very nicely either. This one is the first diamond wheel I ever bought. It's from Poltava in the Ukraine. It also dressed very well. Okay, I've just realised I don't actually have a wheel adapter for this one, so I'll have to turn one of them up another day. Well, I think the setup I've got is kind of optimised for this 150 grit wheel. That came out really nicely. The 600 grit, not so much. It's obviously just, I guess the binder from here clogs up this wheel and then it doesn't cut very nicely anymore. It's better, but it's still not as good as it should be. Right, so let's load up an end mill, the one I was looking at before, and see if the wheel is now flat enough to remove that curvature along the cutting edge and especially the raised portion in the center. Right, so the first and most important thing is I no longer have that bump in the middle, so that's good. I'm now getting to the point where I really need to re-gash the thing. One thing I found very difficult to set up was the primary and secondary angles. Primary is only 3 degrees with carbide end mills, secondary 6. So once you've set the secondary, you only need a very light touch with the primary angle to give you the correct width on the cutting edge here. And as you can see on, I think here, I touched off slightly too hard. So here there's no primary, there's just straight to secondary. So this tooth's not going to cut much. I then reset and got a nice little primary angle on the other 3. I'll use this a bit and see how it ends up. But all in all, I'm very happy with that method of dressing diamond cutting discs. Especially the coarser ones came up really nicely. The fine one, not great, but at least it's got a largely flat profile now, so I can use it. And if anyone from their experience can advise me on a better grinding wheel grit and binder and stuff for such a wheel, for dressing a 600 grit fine diamond wheel, please add it to the comment section. I'd really appreciate it. Thanks a lot for watching.